Good evening, everyone, and a very warm welcome to today's webinar on Power Smart AI data centers, grid aware, renewable ready, and self optimizing. I'm Siddhineni Pandarinath, Director Industry Solutions, leading energy initiatives at Tata Elxsi, and I will be your moderator for this session. AI driven workloads are redefining data centers, driving unprecedented demand for power, resilience, and sustainability. At the same time, data centers are no longer isolated energy consumers. They are becoming active participants in the grid, tightly coupled with renewables, energy storage, intelligent control, and real-time optimization. Today's discussion is focused on how we architect the next generation of AI centers, one that grid aware, responding to the dynamically uh, any grid conditions that come across, renewables ready, seamlessly integrating solar, wind, battery storage, and clean energy, self optimizing using AI and digital intelligence to balance performance, cost, and carbon. We are privileged to have an outstanding panel of industry leaders with us today. Mr. Sugumar Umapati, Chief Technology Officer, India, Dell Technologies. Mr. Emmanuel Daniel, Vice President, Solution Developments, QCell's North America, Mr. Aditya Chikodi, Vice President and BU Head, IDV and System Integration, Tata Elxsi. In this session, we will explore real-world challenges, proven architectures, and emerging best practices for infrastructure and grid interaction to renewable integration and intelligent orchestration. This will be an interactive roundtable style discussion, and I encourage you to reflect on how these ideas apply to your own AI and data center journey. With that, let's begin with brief introduction from our panelists. Let me start with Sugumar.
Thank you for having me. It's a pleasure to be on this panel and to be talking about our perspectives on this very important topic that's on the top of the mind for every organization. My name is Sugumar Mapati. I'm CTO India, Dell Technologies. What I do for customers is help in digital transformation and also help build AI strategies and multi-cloud strategies, essentially helping customers in progressing their challenges towards business opportunities and making it relevant for the business. Thank you for having me.
Emmanuel.
Perfect. Thank you, SP. Good morning, good afternoon, and good evening, everyone. It's a pleasure to be here on this webinar today. My name is Emmanuel Daniel. I am the VP of Solution Development and Engineering for QCells. At QCells, I predominantly focus on design, build, and delivery of advanced energy management solutions. What that typically means is QCells is one of the few companies in the world that is vertically integrated, where we can not only generate power producing assets, but we also drive to help manage them. And our aspiration in this space is because of the heavy and massive energy demand of data centers globally. Our desire is to drive efficiency on how energy can be generated, how energy can be managed, and how it could be provided back into the grid as well. Where ultimately our aspiration is we create autonomous, fully functional agentic operation of data centers and on-site power generation and management, allowing our data center assets to become more efficient and also be able to contribute back to the grid, thereby providing grid stability and resiliency as well. And looking forward to this discussion.
Thank you, Aditya.
Thanks, SP, and hello, everyone. Firstly, it's a privilege to be on this panel along with an esteemed guest from Dell, Suguma Rumapati, and Emmanuel Daniel from QCells. My name is Aditya Chikodi. I am the Vice President and Business Unit Head for two of our businesses, which one or the other way tries to deliver through design, through engineering, through production, an integrated energy management solution that includes working all the way around the devices, the distributed energy resources, and getting into the digital infrastructure that brings various different aspects of energy, renewable, traditional renewables, new renewables, as well as the conventional power sources. Looking forward to having an interesting conversation. Data centers is in center, left, right, center of everything that is happening around us. We have had data centers for ages. We have done DCDR for ages, but all of a sudden we see data centers becoming the need of the hour. More importantly, as data centers flourish, the energy requirements that are driving the conversation and the applications are the questions that would be very keen to discuss and throw some insights and light around. So thanks once again, and looking forward to an interesting conversation.
Thank you, Aditya. Okay, first open questions to all of you is AI workloads are fundamentally changing how data centers consume and interact with power. From your perspective, what is the key challenge or a single biggest shift organization must make to build a truly power smart AI data center? I think Sugumar,
Yeah, sure. I
you'd
think
like to go?
it's a great question. A great question, and I'm thinking definitely it's not one big challenge. We are talking about multiple challenges for sure. What we hear from customers from a Dell perspective, when we look at, we all understand that AI workloads are extremely power hungry. So biggest challenge that we hear from customers definitely is about availability of power in itself. So this is not an infinite resource that is available for customers to leverage and start working on. There is constraints from availability and to be able to make use of them to be able to make meaningful decisions and workloads within the AI. Now, that given that this is a biggest concern that we hear from customers, one of the areas that we also see is how can we drive towards more and more about performance per watt rather than just about unconstrained performance. So how are we able to optimize and leverage the technologies to drive better and better outcomes out of it? Another key challenge that we look at is how prepared are the data centers and the thermal limits within which the boundaries of which everything is being pushed when we talk about AI workloads. Now, starting from the data center availability of power within a rack or per rack or drop per rack, or being able to cool. Today, when we talk about GPUs looking at multiple kilowatts of power per device, what we're talking about is a single rack with typical air cooled solutions may not even be able to sustain the requirements to run AI workloads. So how do we really change, or how do we really work towards optimizing it? And I would say we also do not really have a full visibility into how the power is being consumed and used. For example, the visibility of what is the power usage and what is the performance you're driving out of it, the visibility into it, how can we optimize, and how can we really leverage the best at the best possible time, are some of the areas which we really see big constraints from customers when they're trying to adopt AI technology. From a Dell perspective, when we look at all of these, we see these as opportunities to be optimized, to be able to help customers solve these challenges, to help them progress towards their AI journey, and not look at these as roadblocks. So these are certainly top three that I can come across, but there are certainly a lot more. Maybe I would certainly look at views from QCell as well as from Tata Elxsi in terms of what other challenges could be.
Sure. Emmanuel?
Excellent. Thank you, Sugmat. That was very insightful. The just to set the context, why is this a big challenge today, and what are the constraints that we should talk about? In today's context, if we have to look at a 1 gigawatt data center campus, what does that actually mean, and what constraints is it actually driving for us? A 1 gigawatt data center campus roughly translates to around 8.7, close to 9 terawatt hours per year in terms of energy consumed. Now, if I have to put a cost to that, you'll see there is a huge fraction of energy consumption. Let's take, your average cost of 0.07 or 7 cents that we have in terms of wholesale negotiated power in the US. That comes to around 600 odd million in terms of energy cost. Now, how do you compare that? When we all talk about a gigawatt of power, our references, that is the output a nuclear power plant would actually generate. So if the consumption of a gigawatt is comparable to that of what a nuclear power plant would actually generate, you can just imagine the constraint that it places on the grid. So to drive our AI future, already we are getting into a situation where we have the amount of energy consumption being equal to what is being generated from a single nuclear plant. This creates massive problems for us. And what are those problems? Ideally, the first problem that one would talk about is securing the power, or we call it the gating problem. Where are you going to get that much of energy from? It is just practically impossible for every data center in the world to go connect to the grid. And we are facing these problems in the US, we are facing these problems in Europe, and all across the world, because grids just don't have that capacity to be able to feed the energy demand that the data centers have. Where the importance of on-site generation starts to come in, where in addition to depending on the grid, you will also have to focus on on-site generation, and you have to figure out when do you generate, when do you consume, and what those optional parameters are as you're trying to build out those aspects. The second challenge is, if you're the owner of an on-site generating asset that is consuming power, okay, ultimately everybody is extremely cost driven. If you look at the earnings discussions of almost all of the hyperscalers today, a big focus on all of their sheets has been the cost of operations of the data centers, because consuming energy and generating energy is not cheap. Our goal is to optimize it. So now, with all the energy reserve that you have on your sites, how are you able to monetize it? And that's where the ability to inject back into the grid or to sell back to the grid starts to come in, right? And the constraint is not all grids are set up to be able to take that energy from you that you're going to generate. The third point I would put out is reliability versus optimization. We all need a reliability, and we all talk about uptime. Everybody would have heard of 99.99, the 4 nines, the 5 nines, the tier twos, the tier threes. How are you able to balance this so that, okay, on one side your costs don't grow up exponentially, your grid doesn't get overloaded, but at the same time you've got resiliency within your data center? The last point is around the importance of data centers today. Very soon, if not already, data centers are critical assets. Because they are critical assets, they become prone for attacks. Now, when I'm talking about a substation at a data center or a transformer or a generator, again, if we don't secure these assets and manage these assets, it could lead to catastrophic destruction. Not only outage in terms of communication, but outage in terms of the of the information and the services that they provide. Because today, a lot of our core services rely on AI and the edge, and that's how I would wrap my response to your question, SP.
Thank you, Emmanuel. Aditya.
Yeah, thank you so much. I think this was really very insightful coming from Sukumar and Emmanuel on various aspects of the power and the need. I think Emmanuel went a little detailed and deep into generation of power at the source. If I were to just summarize, right, the biggest shift an organization needs to make as we start talking about data centers and we bring it in context of AI, because data centers have been there for ages, is how do you build a power efficient facility, design intelligent energy ecosystem. It's about converging energy engineering, digital engineering, and sustainability into one cohesive architecture. I mean, just building on where what Emmanuel and Sukumar were pointing out, the data centers of today are evolving from being low density setups to ultra high density setups. So what does that mean is the racks which stack the various different compute engines and storage engines machines, they tend to go somewhere between 2 to 5 kilowatt to going all the way up to 30 to 100 kilowatt per rack, right? That is the energy density per rack. And this translates to the amount of energy that is required to drive certain operations that this data center is going to provide. And with AI, which includes from training to inference generation to generating insights to doing certain compute activities, the density of the rack will continue to grow, the sizes of data centers will continue to grow. And as this continues to grow, there are move shifts that are happening around the kind of electricity, the kind of the power that is currently getting utilized from a power infrastructure and a power distribution point of view. Typically, data centers have worked around 208 to 415 volt AC, which is very common. But with increase in the AI infrastructure, the shift is now going towards the direct current or the DC power. 54 volt DC is at rack level is what we are getting to see today. And with large scale next generation GPUs, AI powered GPUs that are getting installed through the likes of NVIDIA's, AMD, and others, you're looking at potentially 800 volt DC architectures. You can just imagine the amount of power these these data centers are going to require to continue operating. And when you have so much of power consumption, there is definitely, as I think Sukumar alluded to this, there's a lot of heat that is going to get generated. There is a very specific need and focus around how do you manage thermal, because thermal management leads to how the infrastructure itself is built up. Today, most of the data centers are air cooled. You have large fans, and typically, a rack which exceeds, which is between 2 to 5, 2 to 10 kilowatts, are typically air cooled from a environment point of view, which means that you're not just talking about the racks, but also talking about HVAC systems that are going to be power consuming and hence power hungry, adding to your bill. When we start looking at the growth in the size of data centers in terms of the rack power density, we are starting to see a move towards liquid cooled systems, liquid cooled systems that go from aisles to rows to racks. And how do you do direct to chip or rear door heat exchanging, right? So if you really think about all of this and then you bring back the question, I again point out data centers, because of AI, will continue to grow leaps and bounds. We are all almost every other day, I would say now it used to be a few weeks to it became a week. Now every day within 24 hours, there is one or the other new announcement of what AI can do, how AI is going to change our way of functioning, the way of operation. And with that, data centers from micro centers to mega centers are going to continue to grow. They'll come up in places where energy availability by itself will become an issue and challenge. That's where you'll have microgrid architectures, which would probably be installed from generation to battery storage, energy storage systems to manage the supply and demand from grid following, which means they will become part of the grid to manage the frequencies, to forming in places where energy is not available. All of this is going to lead to a lot of energy consumption, a lot of energy generation, a lot of energy consumption, either to run the racks, run the data centers in terms of the racks, or from the HVAC systems and other resources. So for us to really start looking at AI powered data centers, we have to start looking at how do you make this efficient. And to make it efficient, there will be a lot of intelligence that will need to be built into the energy ecosystems. And to build this, we will have to look at energy efficient equipments, thermal and energy management solutions, and an intervention of digital platforms, which will be able to help and manage this in a extremely real-time basis. Yeah, so thank you. I mean, that was my perspective to bring these points together.
Thank you, Aditya. Um, that sets a strong foundation. Let's now go deeper into compute and infrastructure side of this transformation. Now, the question is to Sugumar. AI data centers demand extreme performance, but also power efficiency and resilience. How is Dell Technologies helping customers, including hyperscalers and large enterprises, size their AI data centers for both performance and power efficiency, from server design to cooling to grid aware operations?
Mhm.
Well, that's extremely important to look at, right? So one of the things that we always focus around is we start designing our platforms from a performance per watt, not just about raw performance. And we also heard Aditya leading to some of these topics around how can we make this more optimized. So let's start with how Dell looks at all of this, right? So the biggest component within all of this is the infrastructure in itself, right? So the server design we start with, we look at how can we most optimally drive efficiency within it by leveraging various airflow mechanisms as well as direct to chip cooling technologies and ways and means of optimizing this to run the most best performance per watt that we can deliver out of it. So we invest quite a lot of effort into making our systems extremely efficient. So what we have done in that area is all our systems are today available with Energy Star ratings, and we are also EPEAT certified. So we are working towards more and more efficiency, driving more and more optimization within the design of these infrastructure platforms. Second, when we think outside the infrastructure comes your rack as well as your data center aspects of it. The topics of being able to drive the power per watt better. If you look at most of the legacy data centers are built with about 6 to at max about 10 kilowatts of power per rack. Now, when you look at that, we also need to understand that even the cooling within the data center is built for that level of power consumption. So when we start to suddenly bring in a much larger footprint, essentially when we are talking about larger deployments, when we talk about training kind of workloads, we're talking about certain cases 100 kilowatts. We today have about 160 kilowatt to 180 kilowatt per rack power consumption. So now when we talk about this kind of a density, we're talking about 80 to 20 times increase in the density from a power as well as cooling point of view. How can we really retrofit these kind of dense packaging into traditional data centers? We certainly need to leverage technologies which can deliver very dense heat capture within the rack itself. So Aditya highlighted about the rear door heat exchanger mechanisms. What we have been doing is working with a lot of the industries, and we have produced a technology called PowerCool, Dell PowerCool. What we are doing is here an enclosed rear door heat exchanger mechanism, which provides 100% heat capture within the rack. So thereby leveraging your room temperature water within the data center, we are able to transfer the heat that gets generated out of it without really having to change or re-architect your data center. Of course, we all would love to have better and more dense possibilities and a data center which can handle much lot power per rack within the same infrastructure part, but we certainly can only aspire for it. So we work towards optimizing how we can leverage these capabilities, driving much more density within. And it is not the end, right? So you're obviously going to have much more density coming towards. The next aspect of it, if you really look at, is how can we control or how can we have better visibility into the telemetry of power consumption? How can we optimize it, and how can we leverage the best out of it? So telemetry becomes extremely important. So if you look at Dell Open Manage as well as iDRAC that we leverage to know better about how the power consumption is happening, how can we optimize it to make it run more better for the organization? And one of the last aspects in this area, if you look at, is how can we do it more grid aware? So we introduced a concept called Concept Astro. What we are doing with this is identifying or aligning with the load patterns within the grid, and to be able to optimize or run those specific jobs in a scheduled manner when there is a lesser power demand from a grid point of view. This is something that we are able to build. If you look at from the right from the infrastructure to the grid to having a complete uh, visibility into telemetry as well as the operation part of it, you're able to get better out of this. So these are some of the areas we have been very keenly focused and developing a lot of technologies and IP around it. Essentially, all of this leads to better utilization and to be able to be doing AI adoption a lot more responsibly and focus more and more towards sustainability as well.
Thank you, Sukumar. Infrastructure is only one side of the equation. Let's now look at how renewable and clean energy fit into this power smart model. My next question is to Emmanuel. Um, Data centers want clean energy, but AI workloads are highly dynamic. How can renewables and clean energy keep pace with hyperscale AI growth? How does BESS, EMS, DERMS fit into AI data center energy strategy?
Excellent. No, thank you, SP. I just want to reflect for a quick minute on what Sukumar said, because I think he brought some really key points that really are going to influence how we design our future of data centers. The It is never an either or situation, right? And I think Sukumar illustrated that very beautifully. On one side, you have AI infrastructure, where we are looking at building massive, enormous data centers, housing them with higher density racks. We started with 10, 20 air cooled racks. Now we're talking about 150, 300 kV of liquid cooled racks. The weight of these racks have also gone up tremendously. Your average AI racks today are around 4,000 pounds per rack. For someone that has started working from 2,000 pounds and now all of a sudden you have a 4,000 pound rack, it creates monumental shift, because even structural engineering for managing your data centers is now a big deal. Right? I just can't roll a rack on and set it up and plug it in. It really affects the contracts, and ultimately the balance is very important. Right, and I'll tie this back to why renewables are key. On one side of the world, we focus heavily on PUE. Uh, PUE is extremely important for data centers today. With liquid cooled data centers, we have been progressively been able to lower the PUEs lower and lower. We start at around 1.6, 1.5 traditionally today, with ambient environments, uh, uh, natural cooling, and with liquid cooled cooling coming on top of that, we're able to bring that down to 1.18, 1.2, which is great. But that being said, the density of these chips within our racks are also going up. And that's where the performance per watt metric starts to come in. So while we focus on infrastructure efficiency with PUE, and the performance per watt starts to focus on a silicon plus workload efficiency, combining them is what is going to give us the whole business efficiency aspect of it. And if I do an illustration, I can go from 1.4 PUE to 1.2 PUE for a gigawatt scale, right? And by doing that, I'm effectively freeing up around 200 megawatts of power. With 200 megawatts of power that I have freed up, I can then use that to reduce around $100 million of my annual consumption. Combine that with what performance per watt can do. If I'm going to improve my performance per watt, I can have faster training of my models or reduce the cluster size of my infrastructure, which is significant, which is, phenomenally significant. Now, this backed by renewable energy. Why do we focus so much on renewable energy? One of the biggest challenges that we face with AI workloads is they're not static workloads. If you take a traditional IT workload, for all those who've looked at IT infrastructure, it's a very flatline, stable workload. But with AI coming in, the ramp for AI workloads is extremely fast. So when you talk about ramp, 10 to 30 or 10 to 20 megawatts kind of a ramp for AI workloads can be achieved in minutes. Now, in a few years ago, I'll probably say 5 to 10 years ago, when we talk about a 10 megawatt data center, it was a big deal. We say, wow, 10 megawatts. Today, we're talking about a gigawatt DC. 150, 200, 250 megawatts of a DC have become common knowledge. Everybody thinks it's nothing, but it is a massive impact on how much of energy that is going to do. Because of these ramp ups coming in, I need a way to be able to augment that sudden consumption of power. If I'm not able to balance that with my peak demand, the charges for the grid or the grid may not be able to support that sudden climb and that sudden demand of power. Hence, I need to have on-site generation, and the most stable way to have on-site generation is to depend on renewable sources. Now, there is always a question to say, can I run my data center purely on renewable sources today? Though everybody would like to do it, it is really not possible purely because of the cost associated with it and the infrastructure needed to do so. I cannot use solar for 24 hours a day. It's not going to happen. Hence, solar peaks are intermittent. Okay, I cannot use wind because wind fluctuates hourly. I cannot use and even on the grid carbon intensity also starts to change, which then starts to affect wholesale pricing as well. If I have a flat load, it is easy for me to design something that can be 100% renewable or proceed to that angle, but it is just not possible for me. That's where our whole angle is to do mixed mode energy consumption, where I'm going to have grid interconnectivity. Now, in case of sudden fluctuations or peaks of AI workloads, I will have best storage systems. Best storage systems will then help nullify or take care of the sudden peak in demand that will happen for AI workloads. And depending upon the time of day or the hour of a day and the price on the grid, I can then also switch to renewables. Therefore, renewables working together to help me better manage my power needs and optimize the cost of my data center infrastructure. And that is where today, when we talk about power consumption, it's become such a complex topic. The preference is everybody would like to have grid interconnectivity. The answer as to why is very simple. It is stable, it is backed, it's guaranteed, but it is not going to help me drive and meet the demand of my AI workloads. Hence, I'll have to augment that with other energy sources. I got to find the cheapest way to be able to generate and manage them. Renewable sources are extremely effective to do so. That's why we have PV sources, we've got BESS sources, all the elements coming in. Grids are also renewable in some cases. You've got hydro grids, right? And because of hydro grids, you've got extremely low cost of power that turns up. But then grids have throttling limits that start to set in. So managing my PV plus my BESS aspects also starts to work in to contribute to it. If I'm an owner and I'm locking in millions of dollars in BESS capacity, that capacity is only being used a few hours a day, right? I have to find a way to monetize it. Then I have to take that capacity and and the best way to monetize it is to inject it back into the grid. That's why grid programs that we have, where data center owners can also help aid grid stability, is also a major factor in driving renewables and setup of batteries on these projects. Now, there was a comment, I think, Aditya, that you made in the previous question on the ability to harvest excess heat that comes from the data centers, which also feeds into renewables. The If you have ever walked down a data center conventionally and you see these enormous magnanimous chillers coming in with AI workloads, you don't rely on air cooling as much, but you do have some aspects of it. I probably say 80-20, so 80% of liquid cool, 20% of air cooled, but you still have a lot of heat dissipation that you have to take over with. We also try to say, why should that heat go to waste, especially in cooler climates across the US, okay, or in or in Europe or the Nordics, harvesting that heat so that heat can then be used to be able to, heat pools or heat homes and transfer that back is also a great source of how data centers are also able to contribute back to the society and the community. And we're harnessing that heat to be able to improve the lives of people surrounding that DC. So all these practices are critical. The beauty of the situation we have landed ourselves into, okay, is there is no one answer for all. Okay, the grid cannot 100% meet a DC, neither can pure renewable sources. Today, we would have heard a lot of conversations surrounding the importance of gas turbines and the rise to prominence of gas turbines. If someone looks at it, it's a very funny story. At one time, you felt you wouldn't need it. Now, the demand for gas turbines is so high, they're categorized as long lead assets. So, combining natural gas with batteries, with wind, with solar, merging all of that to be able to balance a DC where we can gain a fine cost of optimization and recovery and stability to manage our peak and AI workloads is what is critical, and the importance of renewables in our data center consumptions.
Thank you, Emmanuel. We have discussed compute, we have discussed clean energy. The real value emerges when intelligence ties everything together. I come to Aditya. My question is how can companies like Tata Elxsi enable the practical integration of renewables, energy storage, intelligent systems? How do AI, digital twin, and real time analytics are helping in operators' efficiency?
Thanks, SP. Very, very insightful conversation. I think Sukumar and Emmanuel have kind of set the platform for me to come in and say where does Tartalix fit in, and where Tartalix fits in is the sweet spot of bringing money of these things together. I like the way Manuel pointed out to the heat that gets generated and how the heat can be converted. The heat that is generated, which is typically because of the power hungry racks and the system, and the various different HVAC systems that are being used to to manage the thermal. How can that heat be translated and converted into other sources? I do understand that organizations like QCell and a few others who work on microgrid technology, on energy generation technologies, tend to have a very high energy generation efficiency, especially when they combine the power and heat together. I believe that's called the CHP applications, right? So to start with that in mind, clearly said that it is about integrating every other aspect of a data center to deliver an efficient solution, right? And Tata Elxsi's perspective is how do we practically integrate various different sources of energy? How do we create an platform which allows, like Emmanuel said, solar power is not available throughout, and when you don't have solar power, how do you leverage the energy that might be available through grids or other renewable sources? So integration of renewables, various different storage energy sources, including best systems, and the intelligent system that can bring all these isolated distributed energy solutions, distributed energy resources together, right? We sit at that interesting intersection. We are an organization, because of its long legacy of more than 35 years, where we have operated strongly in the product engineering space, and over the last decade and more, taken our capabilities and experiences of working on compute, working on networking, working on storage, working on chip programming, bringing all of this together, working with various different OEMs. We have been able to take these core competencies and associate ourselves with the utility companies, the retail organizations, the OEMs, organizations like Dell, as well as QCell and others in this ecosystem, working on microgrids and digital platforms, from being in a role of advisory to actually helping architect and integrate. We're a services organization. We work with many of these organizations. We also work on the application side, such as the data center. So in order to do all of this, like I said, it's not just advisory, but it's also architecture and integrative. Uh, we do not treat renewables and storage as two independent elements. And Emmanuel kind of alluded to this particular point, how all of these integrate together. They come together in an integrated fashion to deliver and drive energy to data centers. Solar, BESS, microgrids, grid interconnections, they all are dynamic. They all have dynamic behavior. The needs, as rightly said, is not going to be flat, but it's going to peak. It is going to go through a trough based on the application of AI within the data center, from training to inference to insights generation. And this requires a coordinated strategy. At a system level design, we need to look at how the grid interconnections are formed. What would be the various compliances around which these interconnections will need to be modeled? These compliances are both statutory compliances, and there also be commercial compliances that would come as a result of the PUEs and the rack density and the builds at which the entire ecosystem needs to operate. What would be the microgrid architecture? What is the source of renewable? Are these the traditional renewables like the solar, wind, hydro, or these are going to be natural gas and hydrogen based? What would be the best capacity that will need to be installed, the sizing for load forecasting, for frequency management? What sort of EMS, what sort of DERMS integration framework we will need to put together? And since all of this is going to be connected, what what are our cyber secure communication requirements, the cyber security needs and requirements? So from compliance all the way to security will all need to be thought through from an architecture and a system level design perspective. And before anything is deployed, from our you can do a sizing, but you before you even go and implement it, it's very important for us to try and model the use case, do some analysis using CAE or fluid dynamics, CFD, creating digital twins, creating an environment in which various different scenarios can be tested and validated. This could go to the density, the power density requirements that was called out between both the gentlemen, going from 10 kilowatt to about 100 kilowatts to 200 kilowatts. What would it mean from a power requirement? What sort of energy generation would happen? What sort of energy consumption would happen? And it's really impressive what QCell has achieved, going from 1.4, 1.6 down to 1.2. And I think that clearly states that how organizations like them are trying to improve their energy performance. And if we were to model this, if we actually work with organizations to create physics informed and data driven digital twin modeling. We compute loads, we can compute thermal loads, you can compute renewable variability, you can look at how a grid can be followed, how a microgrid can be formed, what would be the best storage capacity, what are the discharge curves, right? We take all of this, model it, compute it in a digital twin, so that you can answer certain very interesting questions. Going back to the solar, what if the solar drops by 30% during the peak AI training cycle? What would be your fallback option? How long can a facility stand as an island itself during the grid disturbance? What is the capacity that you need to plan, depending on how close, how far, how reliable and resilient is the grid that is going to power? What is the cycling strategy that you need to have in place to extend the life, so that you are also thinking about not just the storage and consumption, but also the sustainability aspects, which goes on to talk about the carbon impact. Because at the end of the day, the societies, the neighborhoods where the data centers are coming right now, trust me, there are a lot of questions that are being asked, because these are the neighborhoods which are going to see their power requirements getting disrupted. They are the ones who are going to start seeing their bills going up. So how do you create that entire ecosystem to ensure that the neighborhoods don't get disturbed, at the same time this expansion of AI-led data centers also happens. So, we need to, so how do we bring AI is going to drive the growth of data centers at the same time, integrating AI and analytics, leading to predicting and predictive engineering using real-time data. Once the system is live, then we need to start looking AI. Once we have also brought in AI to do certain of these jobs, we can actually look at the GPU load density, the how much of renewables are getting generated, and hence you can do your scheduling on frequency management between the utility grids and the microgrids. Thinking about real-time electricity price signaling to decide on which source of power would you like to use, also taking into consideration the carbon intensity that is going to get generated, right?
Mhm.
So a lot of real-time analytics can be done. A lot of analytics around carbon management is possible, and this is where we bring the at the digital layer, from integrating the various different digital sources to creating AI-based applications. So creating a integrated data fabric layer where all the different types of data can be brought in, and on top of that, write various types of applications that can help you know the SOC value of the batteries, the charge and discharge of the batteries. How do you handle the critical, non-critical loads? When to prioritize the solar, the traditional renewables versus the microgrid, renewables, the demand and response aspects of this, right? At the end of the day, the AI data centers, AI is going to drive a lot of applications. The peaks and the troughs of the AIs are challenges that will need to be managed. Downtime is going to be extremely expensive. Downtime, not just for the data centers, but also the societies and the neighborhoods in which these data centers are going to be set up. It's so important that the grid, the traditional grid, doesn't get overwhelmed,
Mhm.
while the microgrids can also do what they are expected to do and deliver, which is to have, borrowing what Emmanuel said, 5 9, or I would say maybe 100% availability, though that's been one of the challenges. And this is where companies like Tata Elxsi, with its 3 decade long experience of handling core engineering competencies, engineering associated with how racks get designed, from 4,000 pounds upwards racks. How do you make these racks resilient? How do you handle the NVH of the racks to make them modular so that they can scale, to be able to take care of various different issues that might come as a result of the territory and terrain in which the racks are installed, to the technologies associated. How do you cool these? How do you cool the chip to cool the rack to cool the entire environment? Building digital solutions that bring all of these together to monitor at the minimum so that certain aspects can be seen, but also allow the data to be churned through AI, ML, analytics, so that certain strong decisions could be taken around the various different points that I called out earlier. This is where a company like us, which has a very strong design led approach, which has a very long AI native competency of bringing AI as needed. We are not just talking about AI data centers, but embedding AI and analytics as relevant. And then through this approach, orchestration of this, deliver sustainable solutions, right? Cost, carbon, and resilience is where a company like us can really add value. And this is how we are today involved and engaging with our customers in driving, I would say, sustainable AI data center deployment, adoption, and scale.
Thank you, Aditya. Now that we have heard perspective of each of the panelists, let's bring all this together in a broader discussion. Another open round. Uh, my question is looking ahead 3 to 5 years, if you could pick one KPI to judge whether an AI data center is truly sustainable, what it would be and why? Emmanuel, would like to go first?
Yeah, it's a very fantastic question the 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 core answer as to how one would put this across is, I would probably say, one of the most important metrics that we all have to deal with uh, is to reflect a little bit on what Aditya just said. Data centers are integrated parts of the community today. So any metric that we choose cannot ignore that. It was very different from the past where you used to have data centers out of sight, out of mind, in locations that were hard to get to. Now we get urban DCs that are bang in the middle of populated organizations. One of the most important metrics to bring everything together, because a community is a big part of data centers today, is going to be the carbon intensity per unit of AI output, right? Basically saying that how am I going to, because this will allow me to measure and combine grid carbon intensity, on-site generation intensity, PUE, GPU utilization, and workload efficiency. Now, it's very hard to measure and report this because this is a metric of metrics that I'm going to combine and pull together. But as data centers become more intensive, as you're going to go from hyperscale to edge data centers, which are going to be a lot more in the city, in the community, closer to urban locations or bang in the middle of urban locations, I think this will probably be the most important thing that matters. Okay, added to that, we can always get effective system efficiency or true PUE output and clean energy matched hourly, which are very standard metrics that we can start computing out. But the amount of but the carbon intensity per unit of AI output is something that we should aspire to get to. Just like how we evolved our buildings and we went down to look at carbon efficiency for buildings and what that means in terms of how we design and manage our cities. I would say that is probably going to be key in terms of how we design, manage, shape, and expand our data centers going into the future.
Thank you, Manuel. Sugumar,
I'd say the challenges when we look at from adoption of all this and the looking at what outcomes and what benefits AI brings to, I think it's extremely important to look at it from a point of something which we always think about, a sustainable triangle, right? So the level of power that we are consuming to do something, to how we are using or how much of carbon emissions we are looking at as a second angle. The third of how much of resources are we consuming to cool this down. So look at it from the point of the power requirement, the cooling, and the rest of the things that are required for it to work, and the resource consumptions that would help you drive all of these. This sustainable triangle is something that I would look at as a metric that we all should look at to drive responsibly the AI adoption across, while this is something that will keep improving over every organization within the industry, looking at making things more efficient, being more performance for what. All of these responsibilities are going to be part of every entity that is participating in this AI. And I don't think anybody who's working towards this will be able to contribute towards this. Looking at the sustainable triangle is what I would say is the topmost metric I would look for when I look at it the next 5 years.
thank you, Sugumar. Aditya?
Yeah, I think I would echo both what Emmanuel and Sukumar mentioned. But I do want to also contribute and see PUE is definitely going to be the key parameter, the key KPI that is going to drive the efficiency improvement as far as carbon intelligent energy driven data centers are concerned. The lesser, the better. And as explained by the co-panelist a little earlier, the more you go towards liquid cool, the more you draw, Emmanuel spoke about, the more you go from 1.4 to 1.2 PUE, they're able to save 200 megawatts of power. And this freed up power actually translates to 100 million odd dollars of reduction. And actually that power actually can be used further in performance or improving the performance of training. So that's very interesting and important, right? The PUE. If I were to take a step further and say that, what if, and building on what Sukumar mentioned about the sustainability triangle, what if we are also able to measure how efficiently power is distributed within the facility, such as where did the energy come from, what's the in carbon intensity at that moment, how intelligently is the energy being stored, whether workloads are scheduled in a grid aware manner or not, how resilient the systems are. Long story short, the PUE is an excellent KPI to help improve infrastructure efficiency. On top of that, if we were to start looking from a sustainability lens, what percentage of the energy that the data center consumes is as a result of renewables, right? And how this renewable is thereby contributing to reducing the carbon footprint. How intelligently and cleanly is the energy being consumed per unit of computational output? Yeah. So if I were to take this further, then maybe the KPI that I would go towards, in addition to PUE and building on the sustainability triangle, is carbon aware compute intensity. Carbon emissions, real time location based per AI training cycle and inference. Why this KPI? As the AI data centers continue to explode, which is, and rightly said, in all the neighborhoods and communities in which it will come up, it is going to use a lot of energy to operate. And in that process, there is going to be carbon emission. All of us, as all the organizations, all of us have a sustainability charter and goal. We are working towards net neutral, net zero, and net negative. And each one of us will reach that at different points in time. A lot of things are under our control, which is the scope one and scope two, which is how our products are engineered and designed. And some of a lot larger portion of the the energy or the carbon emission is scope 3, which is not under our control, but we can definitely create some sort of supply chain optimization and traceability and visibility in order to bring it under control. But when you look at scope 1 and scope 2, we can directly influence based on the various different, using tools like digital twin and the modeling, look at the workload behavior, influence how our solutions, the hardware, the software, the racks, the grid, the energy management systems, how our solutions which are under our control can be made more energy efficient. And the PUE, if can be measured from a carbon aware compute intensity, can lead to a much more better sustainable solution that leads to, so hence it leads to an integration between compute scheduling, renewable integration, and storage strategy, right? So this is a KPI that I strongly believe with a design-led mindset can lead to a stronger AI-driven orchestration, using digital twin for carbon outcomes, simulating carbon outcomes, analytics that can help manage and integrate utilities better, battery optimization strategies and synergies, and making grid-aware systems, right? So so for me, carbon-aware compute intensity would be one more KPI that I would like to add to the mix of things.
Thank you, Aditya. Very powerful insights. Thank you to our panelists for insightful and thought-provoking discussion. And thank you, everyone working behind the scenes. What clearly emerged from this conversation is that AI centers are no longer just compute facilities. They are evolving into intelligent, energy driven systems. Success in this new era depends on tighter integration between IT, energy infrastructure, and grid, smarter use of renewables, storage, and clean energy, and a strong layer of AI driven intelligence for continuously optimizing performance, cost, and sustainability. The journey to power smart, self optimizing data centers is not about one technology, It's about ecosystem of collaboration where infrastructure providers, energy solution leaders, and digital engineering partners come together. At Tata Elxsi, we look forward to continue these conversations and collaborations with organizations as they design and scale future-ready AI data centers. Once again, thank you for your time and participation. We hope today's discussion provide valuable insights and practical perspective. Have a great day, have a great evening, and we look forward to engage with you again soon. Thank you, everyone.
Thank you.
Thank you.
Thank you.